Bismillahirrahmanirrahim. Welcome to the online lecture series on power electronics. In our last lecture, we discussed about semi-converter, and the topic of discussion for today is full converter. So, starting with the single phase full converter, the circuit is shown in figure 1. So, you can see that now we have 4 thyristor T1, T3, T4 and T2, and the arrangement of circle of this circuit is similar to the single phase semi converter. The load is still the same. We are using a highly inductive load, and we have this transformer as an input source. So the circuit consists of 4 thyristor T1 to T4. That is, the diodes in the semi converter have been replaced by the thyristors too. Therefore, we name it as full converter. And in the semi converters, we had 2 thyristor and 2 diodes. So we had half control over that circuit, but this circuit is completely controlled. During the positive cycle, T1 and T2 will operate, and during the negative cycle, T3 and T4 will operate. With this polarity, in the positive cycle, T1 and T2 will operate. The circuit will be completed via this path. When the thyristor T1 and T2 are both triggered simultaneously with the same firing angle alpha, in that case the T1 and T2 will be forward biased and it will start conducting, and this load RL will be connected to the source side via these thyristors T1 and T2. And similarly, with the opposite polarity, when that is during the negative cycle, when we have a negative polarity over this at this side and positive polarity on this side, in that case T3 and T4 will be operating, and the load will be connected to the source side via these thyristors T3 and T4. So we can fire these thyristor at different angles, but to have a symmetry, we are firing these thyristor at the same angle alpha, and similarly we can fire these two thyristors simultaneously at either an angle alpha or some other angle beta. The same that we discussed in last slide is written over here, that during the positive cycle, the anode of T1 thyristor will be connected to the positive terminal, and the cathode of T2 will be connected to negative terminal. This is the cathode of the T2. It is connected to the negative terminal during the first half, positive half, and the anode of T1 is connected to the positive. So once these thyristors will be triggered, in that case they will start to conduct and the load will be connected to the source. The angle has been kept as alpha is equal to omega t, and then due to inductive load and due to the absence of any freewheeling diode, the thyristor T1 and T2 will continue to conduct beyond omega t is equal to alpha. Well, the positive cycle is from 0 to pi, and the negative half of cycle is from pi to 2 pi. So once the thyristor, we are considering this case from the positive half, so when the thyristors T1 and T2 are triggered at a certain angle alpha in between 0 to pi, in that case load current will start to flow, and it should continue to operate up till angle pi. But due to highly inductive load and due to absence of any freewheeling diode, these thyristor will be forced to conduct beyond the angle pi. This is the similar concept that we have been discussing in case of control rectifier when we discussed about the half wave controlled rectification, or even in diodes we saw that when we have uncontrolled rectification, that is when we used simple diodes, even in that case we saw that when we were using some high inductive load and there was no freewheeling diode present, in that case this angle was conducting beyond omega t is equal to alpha. So same will be the case over here. During the negative cycle, T3 and T4 will be forward bias, and T1 and T2 will stop conducting when T3 and T4 will be fired. Ideally this T1 and T2 should have stopped at angle omega t is equal to pi, but they were forced to conduct beyond omega t is equal to pi due to presence of a highly inductive load and absence of any freewheeling diode. So they were conducting even after angle pi. So they will stop conducting when thyristor T3 and T4 will be fired. Current will flow from T3 and T4 in the duration pi plus alpha to 2 pi plus alpha. This is during the negative half cycle. These thyristors T3 and T4 are triggered at pi plus alpha, and they should have conducted up to 2 pi, but again the reason is same, that due to absence of freewheeling diode and inductive load they are conducting beyond 2 pi. The waveforms that I will obtain in case of a full wave converter are shown on this slide. This is my input voltage, V is equal to Vm sin of omega t, it is sinusoidal, and V naught is the output voltage that is obtained across the load. So you can see that at this angle omega t is equal to alpha, the thyristors T1 and T2 were triggered. So during this time period from alpha to pi, T1 and T2 are conducting, but they should have stopped conducting at this angle pi, but they continue to conduct beyond pi, and the polarity of voltage from pi to pi plus alpha is negative. And when the thyristor T3 and T4 were triggered at angle pi plus alpha, in that case the output voltage that we obtained was this, and just like the previous case in positive half cycle, they also went on continuing beyond angle 2 pi, and they will conduct from pi plus alpha to 2 pi plus alpha. So we are assuming the same thing, that my load is a huge inductor, and there are no ripple in my output voltage, and my inductor is in continuous conduction mode. So this is IA is my output current, and it is available throughout the time period. From alpha to pi plus alpha, this was due to the conduction of T1 and T2, and this is from pi plus alpha to 2 pi plus alpha, this is due to thyristor T3 and T4. So the same is discussed over here, that during the period from alpha to pi, the input voltage V and input current I are positive, and the power will flow from supply to the load. So this mode is known as rectification mode, that is we are supplying current or delivering power to the load, but during the period from pi to pi plus alpha, the output voltage was negative, and the current was positive, but the